we need to resolve the given rational fraction into partial fraction. Now we'll start with the denominator. So here in the denominator we have alpha squared minus 1 whole squared. Now the denominator can be this can be also expressed as alpha squared minus 1 squared whole squared. Now alpha squared minus 1 squared, when you factorize it, so that's alpha minus 1 multiplied to alpha plus 1, and we also have to square it, so we have alpha minus 1 whole squared times alpha plus 1 whole squared, meaning our rational fraction 1 over alpha squared minus 1 whole squared can be also expressed as 1 over alpha minus 1 whole squared times alpha plus 1 whole squared. Since our goal is to split this given rational fraction into partial fraction, so we're going to assume that we have 1 over x alpha minus 1 whole squared multiplied to alpha plus 1 whole squared. We will assume that this can be split into 4 partial fractions. 4 because alpha minus 1, the factor alpha minus 1 is repeating twice, and the other factor alpha plus 1 is repeating twice. The first partial fraction will be a over alpha minus 1 plus the second partial fraction, which will be b over alpha minus 1 whole squared, followed by the third partial fraction, which will be c over alpha plus 1, and the final one will be d over alpha plus 1 whole squared. Fine. So let's label this as equation number 1. Our goal will be to obtain the value of the constants a, b, c, and d. Here what we can do, we can use the method known as the cover-up method to find out the value of the constant b and d. So to find out the value of b, we will consider our original rational fraction, and in this fraction we're going to cover up the denominator of b, which is the factor alpha minus 1 whole square. So we're left with alpha plus 1 whole square in the denominator. Now what we have done here, we have covered up alpha minus 1 whole square. So if we equate this to 0, this simply means that alpha has a value of 1. We can substitute this value to find out the value of b. So b will be equals to 1 over, so in place of alpha if we have 1, so 1 plus 1, which is 2, 2 squared will give us a value 1 over 4. Similarly, we can use the cover up method to find out the value of d. We take the original rational fraction and we cover up the factor alpha plus 1 whole square, because that occurs in the fourth partial fraction as well. So we have 1 over alpha minus 1 whole square. What we have done here, so we have covered up alpha plus 1 whole square. So if we equate it to 0, so that means alpha value will be negative 1. So we'll substitute this here. So d value also comes out to be equals to 1 over 4. Now that we have obtained the value of b and d, our goal will be to find out the value of a and c. So let's do that. For that, we are going to take equation number 1 and multiply throughout with the denominator, which is x minus 1 whole squared and x plus 1 whole squared. Equation 1 will then become 1 on the left hand side, and on the right hand side we have alpha minus 1 multiplied to alpha plus 1 whole squared times a. This is the first time for a term, followed by the second term, which is alpha plus 1 whole squared multiplied to b. The third term is going to be alpha minus 1 whole squared multiplied to alpha plus 1 times c, and the fourth term will be alpha minus 1 whole squared multiplied to d. Now this is an equation which is an identity in alpha. So since an identity in alpha, we're going to consider few values of alpha. We're going to first consider alpha equals to 0. So if we take alpha equals to 0 and we substitute alpha equals to 0 into this entire equation, this is going to give us 1 equals to negative a plus b plus c plus d. Now we already have obtained the value of b and d. So b and d came out to be 1 over 4. So we have 1 over 4 to place in place of b and d. So this gives us the new equation. So we get a minus c equals to negative half. So we're going to keep this equation aside, and then we're going to consider another value of alpha. So we have alpha. If we take alpha equals to 2, then we're going to get the new equation, which is 1 equals to 9a plus 9b plus 3c plus d. And since we have already obtained the value of b and d, so we have 9a plus 9 over 4 plus 3c plus 1 over 4. Solving this equation, we get 3a plus c equals to negative half. So let this be the next equation. we're going to label this as equation number 2 and equation number 3. So when we solve equation 2 and 3, that's a very trivial exercise. So solving for a and c, we get a value as negative 1 over 4 and c value as positive 1 over 4. So hence we have obtained all the values now. So we have obtained b as well, which is 1 over 4, and d as well, which is 1 over 4. We can substitute this back into equation number 1, and this is going to give us the final value. So let's do that. Thus our final value, the original rational fraction was 1 over alpha squared minus 1 whole squared. So here we have the negative 1 over 4 times alpha minus 1 plus the b value, which is 1 over 4 times alpha minus 1 whole squared plus 1 over 4 times alpha plus 1 plus the fourth partial fraction, which is 1 over 4 times alpha plus 1 whole squared. So this is the final value.